Power transformers are critical components for the supply of electrical power. Load and ambient conditions accelerate aging and sudden failure. There is always a high risk of failure when critical components are not monitored. It is in the interest of operators to ensure their longevity. Almost every failure can be traced back to the failure of the insulating system, so the winding temperature is the most important factor. Winding temperature indicators are normally used for the operation of the cooling system, and when they are accurate, they can minimize a large temperature fluctuation and ensure that cooling only kicks in when necessary. This ability can be increased by using temperature monitoring devices with communication capabilities and converting the device from a single monitoring relay to a temperature management tool. The ideal winding temperature indicator will precisely reflect the behavior of the windings of a transformer, immediately indicate the highest temperature under all load conditions, and initiate appropriate cooling measures. The MTeC EPT202 generation of devices meets these requirements, and then some. Imprecise temperature monitoring can cause hot spots in some transformer applications and unnecessarily low load limits in others. Pumps and fans which run even when they are not needed cause an unnecessary high amount of wear. In the worst-case scenario, they must be completely replaced. The load-dependent temperature monitoring of the MTeC system controls transformer temperatures within the required limits and simultaneously reduces fan and pump operation to an absolute minimum. The additional load change circuit ensures that the individual fans are equally loaded. All temperature and fan control is based on proven algorithms from the IEC and ANSI standards. The lifespan of your transformer depends to a great extent on thermal aging of the insulation materials. The MTeC calculates for you the percentage of lifespan which has already been used. The most important functions on the device, such as power, alarm, trip, error, and the operational state of the individual fan groups, can be seen at a glance on the LEDs. The well-organized central display indicates all device information for operation and programming of the MTeC system for each menu item. Navigation through the individual menu is child's play using the cursor keys to the right of the central display. You are guided intuitively through the individual function areas. Based on which sensor you use for measuring the top oil temperature, the input parameterization can be selected as desired. The outputs of the MTeC can also be set as desired. If you want to connect another device later on, just parameterize the output again. You can configure the individual switching contacts so that they are allocated to either the oil or the winding temperature. In addition, you can switch each fan group by hand. For correct forecast of future temperature peaks, accurate knowledge of the past is necessary. The menu item Peak Value is an easy-to-use version of the mechanical drag hands. Min-max values for the oil and winding temperature and the maximum load current are logged and indicated. And if you want to know what your transformer has been up to during the last few months, MTeC will reveal everything with its data logging function. Just download the data with a PC. The easy-to-use Windows-based software lets you make all the settings of the MTeC even from a remote PC away from the transformer. Click on an extra module to expand the functionality of the MTeC system with additional circuits to monitor winding temperature and oil level. We are talking about function modularity here. It is important to measure the winding temperatures of all transformers which are equipped with cooling systems to increase loadability. Such transformers require precise measurement of the winding temperature to ensure that overheating does not damage the insulation of the transformer. An evaluation of the maximum economic efficiency which can be achieved during operation depends on accurate monitoring and realistic operational and maintenance strategies. Since power providers are also forced to increase utilization of their systems while employing fewer personnel, a change to these new systems is vital to survival.